So, you guys have any questions at this point? I think we've done just the very beginning of chapter 3. I've assigned that worksheet 1 from chapter 3. Does anybody have any questions on that guy? Okie doke. Well, today the plan is going to be to kind of be going, well, backwards kind of. So prior to this, we went from like an equation, and then we used that to generate the graph. Today, we're going to be going from the graph and trying to generate the equation. Everybody's okay with that plan? So there's like two main tools that we're going to use to do this. I want to remind us of, we had these 3 definitions about the attributes for these sine and cosine functions that we talked about before. So amplitude, midline, period. And then we are going to combine those ideas with these formulas that we talked about last time also. So what we're going to do is we're going to use the amplitude from our picture. Oh my goodness, I can't see it. Why is anybody saying anything? It's like, Mr. Kulik, I can't see anything you have on the board there that you're talking about. No, I didn't know. Why would I, how would I know if I'm referring to things like I'm doing stuff on the computer with the pen and you guys are just sitting here like, he knows what he's doing. No, I don't. It's clearly an accident. So again, we have these 3 definitions for amplitude, midline, period. What these are going to do is allow us to visually find those values on our graph. From those values, then, we're going to be able to figure out the coefficients for A for amplitude, the K for midline, and then the C from the period. And then we'll talk about how to get the rest of this out of here, or out of our problem. Do that real quick. So let's do an example here. Okay, so let's do some examples here of how we're going to kind of use these ideas to go backwards through this. I don't like the way that came out. Let me get a better picture here. Oh, that's so big. All right, so let's say that we're given a graph that looks like this. So I'm going to first start by identifying my midline, my amplitude, and my period. And I'm going to use that to kind of start figuring out values for A, C, and K. The one I always like to start with is the midline. So our definition for midline says it's the line that cuts the wave in half. It lies halfway between the maximum and minimum values. So if I look at this picture, where does it appear the midline is? the x-axis. Good job, Luca. So that looks like our midline. Half of the graph is above it, half of the graph is below it, right? So the x-axis is the horizontal line y equals 0 because the y-coordinate on every point on that line is 0, right? So I know that the midline is y equals k, so that tells me that the k is 0. Questions so far? Okay. The next thing I'm going to look for is the amplitude. So our definition says the amplitude of a wave is half the total height of the wave. It is half the distance between the maximum and minimum y values. So that's the same thing as the distance from either a max or a min to the midline, right? So if I look at this one, let's say, that appears to be our amplitude. You guys agree with that? If I count, we start at 0 and we went up to 2. So the amplitude is 2. Everybody's okay with that? We know that the amplitude is the absolute value of A. So I know the absolute value of A is 2, which tells me then that A has to be plus or minus 2. We'll decide which one it has to be when we finish writing the equation. But for right now, we've got it narrowed down between any number to 2 numbers, which is pretty good progress. So that's the second thing I look for. The third thing I'm going to look for is the period. So let's go back and read what that says. The period of the wave is the length of one full cycle of the wave. Okay? So if I start on the midline, I do an up, and then I do a down, and then I end back at the midline. So that's like one full period there. Thank you. And how far is that? Well, we're starting at negative 2 pi and ending at positive 2 pi. So my period should be 4 pi. So far, so good. I know from my list that one period is 2 pi times the absolute value of c.
Why was it 4 pi?
Because I start at negative 2 pi and ended at positive 2 pi. So like here to here was 2 pi, and then like there to there is 2 pi. And if I solve that for the absolute value of c, I would divide both sides by 2 pi. So the absolute value of c is 2. Or that c then is just plus or minus 2. So again, I've narrowed c down from any possible number to 2 numbers. Again, not perfect. I'd like to get it down to just one thing, but down from infinitely many to 2, pretty good progress by just kind of looking at the picture, right? Questions so far? Okay, so now we're going to have a little bit of choice here because it turns out that there's kind of infinitely many ways to write a correct answer for this problem. So depending on how we want to write our correct answer, we're going to have some choices. So the first choice we're going to make is we're going to choose C to always be positive. We can write answers where the C is negative that are correct, but I don't think it ever makes life easier. I think it always is either easier or stays the same if we just choose C to be positive. Since there's always an answer where C is positive, I'm just going to always make C positive when I do these. I would suggest you to do the same, although it's not necessarily going to be incorrect if you try to make the C negative. But this is the way that I'm going to do it. Everybody's okay? All right. Now what we need to do is we need to decide whether we want to write this as a sine function or a cosine function, because it's possible to do either. I'm going to do it both ways so you guys can see the difference. Everybody's okay here? Now, what I'm going to do is I'm going to choose a point from the parent function of sine and find a corresponding point to that on my graph. So when I'm going to do sine, the point that I'm always going to use is going to be 0, 0. And if I remember the graph, what the graph for regular old sine looks like, it looks like this. So this point 0, 0 is a midline point. Preceding the midline point is the minimum. And following that midline point is the maximum. So I'm going to write that next to it to remind myself of what kind of midline point I have. Now I'm going to go to my graph, my resultant function, and find another midline point. So if I go up to my graph, I see 1, 2, 3 possibilities to choose. Does it matter which one I choose? No, but my answer will be different depending on which one I pick. Everybody's okay there? The midline point I'm going to pick is going to be this one here at 0, 0, because frankly, the coordinates being 0, 0 makes the numbers easy to deal with. Now, the other thing I need to look at from my graph is to look to see what precedes that midline point, which is a maximum, and what follows that midline point, which is a minimum. By comparing those, I'm going to get the information to tell me whether A should be positive or negative. Notice that those are reversed, right? That the parent function was minimum, midline, max. The point I've chosen from my resultant function, max, midline, min, those are opposite, right? So I figured out my value for A now. So I have A, I have C, I have K. I know in this case I'm writing a sine function. There's one more thing we need to figure out, and that's H, right? So I looked at what type of midline point I had in my function compared to the midline point from sine. So from the parent function, from sine x, it goes minimum, midline point, maximum. On my picture, the midline point I picked at 0, 0 goes maximum, midline point, minimum, because those were the opposite order. That tells me that the sign for A is opposite. It's the negative. If they were the same, it would tell me that the A should be positive. Is everybody okay with that? All right. So to find H, what I'm going to do is I'm going to use this idea from graphing that I can take a point from the parent function and transform it to a point in the resultant function by doing cx plus h, ay plus k. So the point from our parent function that we chose was 0, 0. We found that our c was 2. The h we don't know. The a was -2. And the k was 0. And that somehow has to end at the resultant point, 0, 0. So if I simplify this, 2 times 0 plus h is just h. -2 times 0 plus 0 is 0. So that tells me that the h is just 0. So now I have everything I need. So I can plug everything in. So I have y equals a times sine of 1 over c times x minus h plus k. So I just plugged in my values. And if I want to simplify that down, I just end up with y equals -2 sine of 1/2 x. Everybody okay? How could I have gotten a different answer here? Well, the most obvious place is, well, what if I had used this point instead of 0, 0? Right? Would have given me a different answer. Or I could have used this point instead of 0, 0. Would give me a different answer, right? The A could possibly be different, and the H could possibly be different. But they would still, if I graph the two things, give me the exact same picture. Okay. Let's see what happens if I'm using cosine as my parent function. If I'm using cosine from my parent function, I'm going to use the point 0, 1. Again, remember the graph of cosine kind of looks like this, where 0, 1 is a maximum. So what I'm going to do now is I'm going to go to my resultant function, and I'm going to choose any extreme point, either a max or a min. Either is fine. So I'm going to go ahead and choose either this point or this point. It doesn't really matter. I'm going to choose this one. So that is the point pi comma -2. And I'm going to observe that that was a minimum. Now, to decide whether A should be positive or negative, I'm going to compare the type of extreme point I have. Since they are opposite types, what does that tell me about A? That it's negative. And I'm going to set up the same transformation map here. So I'm going to go from 0, 1 in my parent function. And I'm going to transform that by doing c times x plus h, a times y plus k. And I know that has to equal the point pi over 2 -2. When I simplify that down, 2 times 0 plus h is just h. And negative 2 times 1 plus 0 is negative 2. So what does h then have to be? Has to be pi. So if I write this all out, I have y equals a times cosine of 1 over c, x minus h plus k. Or if I wanted to simplify this out, that would be cosine of x over 2 minus pi over 2. Bless you. I think that was a sneeze. No? Maybe not. Yeah, I thought it was one of those, like, I'm holding my sneeze in sneezes. It sounds like your eyeballs are going to pop out of your head or something. I can't do them. I just let them rip. Yeah, it's not satisfying. I just, like, get it out. So that's not trivial, that process, right? That's a little bit tricky. The nice part is the way that we're approaching it, it's like the same problem every single time. So we can kind of take this same approach every single time. Let's do another just to kind of practice that up some more. What do you guys say? So my plan today is just kind of doing some examples of doing this type of problem. And this is the problem you're going to be doing in your homework. So we're not really doing any new content, right? All the ideas that we have looking at here are ideas that we've already kind of built in the previous lesson. We're just looking at like a new application. Of doing these things. Make that a little smaller. Zoom back in. Okay. What do I start with trying to find first? Who remembers? Midline is correct. Good. What is the midline in this picture? Looks like it's going by ones. That's 1, 2, 3, 4. So I guess it's going by halves or whatever. Yeah. So it's the line right here, y equals 1. That tells me the k is 1, right? Next thing we'll look for is I'll do the amplitude. Now, it doesn't really matter. We could do period. I'm going to do amplitude next. So what does the amplitude appear to be? 1. So that tells me the A is plus or minus 1, right? Notice I'm writing a little less work this time just because after we understand like where this stuff is coming from, it's not necessary to write down like all these little trivial little steps. I'm just going to clean this up a little bit so it doesn't feel like I'm writing down a paragraph to do this problem. Okay, let's do the period next. My suggestion here, since there's a lot of periods here to look at, sometimes that's hard. I'm just going to go from like one minimum to the other minimum. You can go from max to max. You can do midline to like next, like one, like, and then 2 midlines later or whatever. I like to go, when I'm given a bunch of periods like this, just go max to max or min to min because it's really easy to identify where they're at. Is everybody okay there? So we're starting at negative half pi. And we go to positive half pi, so the period is pi. So if I calculate that period by doing 2 pi times the absolute value of c, and that has to equal pi, what does c have to be? If I divide both sides by 2 pi, I have 1 pi over 2 pi, which simplifies down to a half, right? 1/2. And we're always going to choose the c to be positive. So I'm not even going to write the plus or minus. I'm just choosing it to be positive straight away here. Everybody's okay? Yes, sir. That's how you calculate a period from an equation. Once we found the period from the graph, we can use that to get the c out of from the equation. Yeah, exactly. Yep. So because we're trying to go from the graph back to the equation. So we're going to use those same formulas to translate where we can. But if you notice from our list of stuffs up here, there's nothing that involves h in the stuff that we could observe, right? Nothing up here involves h. So that's why the h part is a little bit tricky at the end. So just like before, let's do this 2 ways. We'll do it as a sine answer, and then we'll do it as a cosine answer. Do you have to do it both ways? Not unless the direction asks you to. Okay, if the direction just says, write the sinusoid equation for this graph, then you can do it as a sine or a cosine, your choice. Or the directions might say, write the sine equation for this graph, and it's telling you to do it just as a sine answer. Or it could say, write the cosine equation for this graph, and then it tells you to do a cosine. Or it could say to do both, right? It just depends on what the directions say. Would you encounter some of each of these types of problems? Yes, right? Where it asks you to do any one you want, this specific one or that specific one or both. You'll run into problems in your homeworks where we ask you to do any of those situations. Okay, for sine, we know that we're always going to be using 0, 0, which is a midline point that is preceded by a minimum and followed by a maximum. If we go to our graph, if we look at our resultant function, we have lots and lots and lots and lots of midline points to pick. If you ask me, the one that I would choose would be that one. The reason is that it's got the smallest x-coordinate, and the x-coordinate's not negative, right? If I don't have to deal with a negative, I'm not going to deal with a negative. You know, like, if I can pick a smallest number I can, I'm going to pick the smallest number I can, just because it's like, seems like less of a hassle to me. Is everybody okay with that? That point is pi over 4, 1. And that point is preceded by a maximum and followed by a minimum. So if I compare the type of midline points I have, what does that tell me about the A? It's negative. So far, so good. Now I'm going to find the H, because we've got everything else, right? We've decided it's a sine function. We know the A is negative. We've picked the C to be positive. We knew the K was 1 to start with. We're ready to go. So what we're going to do is, I know to transform 0, 0 into pi over 4, 1, I'm going to be doing C times x, which was 0, plus h, a times y, which is 0, plus 1. And that has to give me the point pi over 4, comma 1. So 1/2 times 0 plus h is just h. -1 times 0 plus 1 is just 1. What does that tell me h is then? It just tells me it's pi over 4. So if I write my equation, I have a times sine of 1 over c x minus h plus k. Or if I simplify this down, I would get that. Because really 1 over a half is just 2. Now I distribute the 2, I get 2 pi over 4, which reduces to just pi over 2. So you see, like, once we're kind of get comfortable with this, this process goes quite a bit quicker than the first time through. But it's going to be slow at the start, right? And that's okay. It's okay. It's supposed to. So far, so good? Okay. Let's do the cosine version now. So for the parent function cosine, we're always going to pick 0, 1, which is a maximum. So now on our graph, we're going to pick any extreme point. The one that I would choose would be 0, 2. Again, the x-coordinate is the smallest one. That sounds really good to me. And I noticed that that was a maximum. Because they're the same type of extreme point, what does that tell me about the A? Positive, right? Because they're both maxes. Everybody okay there? Okay. So now we're ready to find H. So we know to do that, we're going to take 0, 1, and we're going to transform that doing C times X plus H, comma, A times Y plus K, and that should give me the point 0, 2. So 0 times a half plus h is just h, and 1 times 1 plus 1 is just 2. So I notice here that h is 0. So I have y equals a times cosine of 1 over c x minus h plus k. Or this just simplifies down to cosine 2x plus 1. Feel okay? Let's do one more. Hi, Miss Yarrow. How are you doing?
I'm fabulous. How are you, Mr. Fuller?
Doing good.
Okay,
Is this for me?
that's for you, and that's for your testing room kids tomorrow.
Oh my goodness, they're gonna be thrilled.
I think they'll be thrilled.
Soft and chewies.
Yes, chocolate chippers too.
Those are the good ones.
Oh, that's
What do you think's in here, guys? Snacks. It's good to be the teacher. All right. I'm going to put 10 minutes on the timer. Try as much as you can on your own for 10 minutes. After 10 minutes, we'll go through this together, but get as far as you can in 10 minutes. 10 minutes is longer than you think. So again, we start by finding the midline, and then the amplitude, and then the period. I would hope that at minimum we can accomplish those three by looking at the picture, because we're not using really anything other than our eyeballs. Yes, sir. Well, the amplitude is always going to be a positive number, but the A value could be positive or negative. Who are my mint people? Oh, that's a terrible throw on my part. Anybody else a mint person? How about a lemonade packet? Anybody interested in that? That's all you, Khalil. Spread the wealth, you know. I feel better about it than throwing it away. So right click up here and hit sync status and hit sync all and tell me if you're getting the errors underneath. Joey. So those are eighths. So like each grid line is an eighth of a pi. So like this is -1/8, -2/8, -3/8, -4/8. So you can just count the eighths. I think it'll come out to a nice even number for you. Sergio, did you get underneath your 6th hour? Did you get errors under this when you did that? Okay. Well, we're in 1010 in the content library. actual word here. So clear that. Close this book. Now, errors. Go back. Right now, you should do it.
So speed, so negative 5/8.
Yep.
And then 3/8.
Yes.
So negative 5/8 plus 3/8.
Well, it's just count. So you will go 5/8 to get back to 0, and then 3/8 more. So it's 8/8.
Oh, 8/8.
I made sure that it was not going to be like an obnoxious value, so it's not like super duper weird. I wanted the arithmetic to work out so it doesn't feel like you're doing it wrong.
The minimum, midline, maximum for parent function and the results function.
So the stuff for the parent function that we picked is always the same.
Yeah.
For the resultant function, it depends on which point you picked. And you're just looking at the picture, like what comes before the point you picked and what comes after it.
So I just choose any point on the midline?
Correct. So say you picked 1/8 pi comma -2.
Yeah, 1/8 pi, yeah, that's what I'm doing.
So the preceding that is a maximum and following that is a minimum. Because if you look at the picture,
You see that in the maximum.
right before that midline point is a maximum, right after it's a minimum. So I'm literally just looking at the picture when I do that.
The 0, 0, is it always going to be 0, 0 for the parent function?
Yeah, the parent function stuff is the same for sine every time, the same for cosine every time. And I guess I should say, so on this, every time I've used sine, I've used this point from the parent function 0, 0. And every time for cosine, I've used this point from the parent function 0, 1. There's nothing magic about why I've chosen to do these particular points. I've chosen to use these because it makes the problem easier. Because the x-coordinate is 0, it makes finding the h much easier than if the x-coordinate was like pi over 2 or something. Like, that's the only reason why I'm choosing to use these points when I do sine and cosine, is because the x-coordinate is 0, and it makes the arithmetic later on when I'm finding the h really a whole lot easier. But I don't have to do that, right? I'm just choosing to do it to make my life easier. And I guess I never said that explicitly, but we should probably say that, right? All right, get ready for it. That's the 10 minutes. All right, let's go through this one here. Even if you didn't finish, that's fine, right? Let's just kind of go through and you can pick up where you had left off. So I always start by finding the midline first. So I know that my k is -2. If I look at my amplitude, that's 1. So my a is going to be plus or minus 1. If I look at my period, so I'm here at 5/8 pi to 3/8 pi, so that's 1 pi total, or -5/8 to +3/8. So my c has to be 1/2, and I'm going to choose that c to be positive. So that's all the stuff from the graph. If I choose my parent function to be sine, I'm going to be using the point 0, 0, which is a minimum, midline point, maximum. For my resultant function, I'm going to choose the midline point here, which is positive pi/8, comma, -2. That is a maximum midline point minimum. So that tells me that the a value is negative. And if I write my transformation, 0, 0 is going to go to pi/8 by doing c times x plus h, a times y plus k, which should give me the point pi/8, comma, -2. 1/2 times 0 plus h is h. -1 times 0 plus -2 is -2. So that tells me my h is pi/8. So if I write my equation, then I have y equals a times sine of 1/c x minus h plus k. Or if I simplify this all down, I'd say y equals negative sine x times 2, or of 2x minus pi/4, and then -2. If I did this as a cosine, I'm going to be using the point 0, 1, which is a maximum. So I'm going to choose some other extreme point from my graph. Maybe I'll choose this one here at -pi/2, or -1. -pi/8, excuse me, -1, which is also a maximum. That tells me that the a value is positive. And then to transform 0, 1 to -pi/8, comma, -1, I have to do c times x plus h, and a times y plus k. So 1/2 times 0 plus h is h. 1 times 1 plus -2 is -1. So that tells me h is -pi/8. So y equals a times cosine of 1/c times x minus h plus k, or if I simplify this all down, have y equals cosine 2x plus pi over 4 minus 2. This is where I'm going to stop today. What you guys are going to work on for your homework here is going to be worksheet 3 from chapter 3. Put that here. So again, what you're going to be given is a picture. I've went ahead and labeled some points on the picture that may or may not be helpful to you. We're asking you to write it as both a sine and cosine function, your answers. There's 4 graphs. That's the assignment. I'd start working on this now. You can take the remaining, I don't know, like 25, 30 minutes here left in class to work. Should be able to get a problem or two done kind of in that time. Be good to start now, where if you get stuck, you can ask questions from somebody that knows what the heck they're doing. But notice as we're doing these problems, with the way that we're approaching it, essentially every single problem is the same, right? They're like all kind of the same problem, which is really nice, that everything can kind of be done the same way. You don't have to like make any special concessions or anything. As a preview to next time, we're going to be kind of doing the same thing, but instead of giving you the graph, giving you all the possible information, we're just going to give you a little bit of it. So we give you some stuff in words, and we're going to have to piece together the equation from these situations. So it's going to be a little bit tougher next time, but that'll be next week. Everybody cool? So to review for Sunday, what am I expecting in the problem set? So for Sunday, I'm expecting just the chapter 3 worksheet 1. For next Sunday, this worksheet 3 is going to go in there. And then anything else we kind of get assigned next week on Tuesday would also go in there. Okay? So far, so good? Okie dokes.